Conductor is an open-source microservices and workflow orchestration platform which originated at Netflix. Boney Sekh co-founded Orcus Inc., a company focused on offering Conductor as a service. Boney joins the show to discuss how engineers leverage Conductor to build highly reliable distributed applications using microservices architecture.
Boney, welcome to the show.
Thanks, Jeffrey. Thanks for having me.
Have you ever hit a technical snafu while shopping online? I sure have, and it's extremely frustrating. There's rarely anyone to reach out to, and I feel kind of stuck. Capital One believes everyone deserves better banking. This means easier access to your money and more security. And that's why Capital One is investing in machine learning. They're using it to fight fraud, making payments easier for all of us and safer for merchants to use. They also leverage causal models for anomaly detection, and they're investing in ways to use machine learning to speed up online shopping at the edge. Their virtual card numbers can make things smoother and more secure. They have technology that can run logistic regression models right there in your browser. A tool like that is exactly where you need it to be in order to identify payment fields and help you create virtual credit card numbers easier and faster. The potential for machine learning is so big. See how Capital One is using machine learning to create the future of banking. Capital One, what's in your wallet? Visit CapitalOne.com/ML for machine learning.
You work on Orcus. That is the correct pronunciation, right?
Yes, Orcus. Orcus is our company. Yeah.
Okay, Orcus, it's an orchestration system for microservices and workflows, originated at Netflix. And I want to start the conversation with a discussion of some previous technologies that are in this area, microservices and workflow orchestration. And when I think about microservice orchestration, the first thing that comes to mind is Temporal and the Cadence project, which is a workflow engine for long-lived workflows, but I would classify that more as like a microservice orchestration system probably. And then there are systems for more complex workflows, like data-driven workflows that, you have the family of Airflow Prefect and Dagster. So I think of this class of technologies of microservices and workflow orchestration systems as encompassing some of those different technologies. I think those are the ones that people who are listening are most familiar with. So maybe we could start off with just your perspective on those technologies that are perhaps better known because they've been in the market for longer. And maybe you could just, give your perspective on them, strengths and weaknesses, and we can use that to segue into a discussion of what you built at Netflix.
Yeah, sounds good. That's a great question, by the way. So workflows and the need for workflow engines have always existed, right? I think there's a ton of products out there that you called out. I was also listening to a podcast about Union.ai the other day. So that's also a very similar product in the space. But I think when it comes to a few of them, like you called out, they're very specific to use cases around the ecosystem of ML and AI, some of them. And then others are like there's something called as Camunda out there as well. I don't know if you mentioned that, but it's called Camunda. It's also a workflow orchestration engine.
Okay.
Yeah. So, some of those are like meant to run smaller scales of workflows, especially based on some of the pricing models that we've seen on their portals. And I think what makes Conductor different is a bunch of great features it has. And I think I can talk a little bit about that. But before that, maybe I should tell about a little bit of history of how Conductor came to be, right? It has been around since 2016. So I think it was around the time when Cadence first originated as well in Uber. So it's been around for a while, although it has been less popular because I think we haven't done a lot of outreach or evangelization of this product as much as some of our peers have done. So this is what we want to come in and do right now. So when it comes to features that makes Conductor different, I think the idea of Conductor is that it decouples the flow logic from the implementation. And I think this is unique about Conductor. And this offers a lot of flexibility when it comes to configuring your flows and running it, because your flow doesn't have to be coupled with your implementation, which means you can run different versions of your flows in production. You can have different variants of the same flow. You can run an A/B test by routing a small percentage of the traffic towards a new version of the flow that you have configured. So there are all these features that makes Conductor unique and special. And Conductor also comes with like the visualization and observability tooling. So you can visualize the execution before it starts. And also each of your execution can be visualized after, and you can see the path it took and the path it didn't take. A lot of the services that we talked about earlier only shows you the steps that actually ran, but that doesn't really fully paint the full picture, right? So that's what makes Conductor unique as well. And there's a lot of tooling around the support as well. Conductor as a platform allows you to restart, retry, pause, resume workflows. You can skip steps. And these are all things that comes into play after your day one of development, like, the day two up until however long the service lives. And these are all like some of the features that makes Conductor unique, which I don't think I have seen in all the other products that are out there. And one unique power of Conductor is it's also designed to run besides your existing infrastructure, meaning it's designed to integrate with your brownfield applications, services that were already running in your production. Sometimes people call them as legacy services. Conductor makes it really easy to onboard onto those services as well, which means running your legacy applications alongside your modern infrastructure becomes easier. So I don't know if I covered some of the points you were looking for, but I can go into any one of them in depth.
No, that's a great overview. I think maybe the next place we could go is to talk about some specific use cases, like if there's a specific type of workflow or example workflow or prototypical workflow that would be good to cover. You've got a lot of different customers at financial institutions, infrastructure companies, Tesla, who I don't know if they're the customers, but they're at least users of Conductor. So maybe you could talk about some of the prototypical workflows that are a good fit for Orcus.
Yeah, Conductor, like you said, right, like you noticed, it's used in different industry verticals. I think we like to see it as a truly generic orchestration system. So it can be used in the world of AI, ML, for example, or even for your business flows. But we try to focus more on the business flows as much as possible. So I can give you a few examples. Maybe that's a good way to talk about the use cases. I'll start with a few things that we're using this at Netflix for. So one of the big use cases of Conductor is how we ingest the media content that is coming from all of the productions that are happening for Netflix. So, different studios across the world is producing content for Netflix, and there's daily cuts, production files, all kinds of resources and outputs from every production process. These files need to be ingested inside Netflix. And this is built using a platform that is backed by Conductor. So what happens is each of these files come in, and there is a ton of flows that need to happen. One file maybe just directly goes into an S3 bucket, but another file needs to go through an approval process, or another file needs to trigger a big chain of processes that need to happen. So all of these flows are configured in Conductor and deployed. And this is one use case that we see people using it for media workflow orchestration. Another use case at Netflix, and this is actually linked to how the users use the Netflix UI. So when you watch content on Netflix, there are issues that you run into. Subtitles may not be in sync with the audio. There are playback issues. So these are things that you can actually report problems using the web UI of Netflix. So what happens is we collect these reports, and there are really complex flows that needs to run, including human-driven tasks to reach a resolution for these problems that the users are reporting. Sometimes they run into like hundreds of steps. So this is another use case where Conductor is used to configure those very dynamic, nuanced flows for each type of issue that the users report, and seeing that through to a resolution. All in all, there are hundreds of millions of workflows that runs at Netflix every month. And I can also mention a couple of use cases that we recently talked about in the meetups that happened in the last couple of months. So there's this fintech company called Black Diamond from Advent. They use Conductor heavily across all of their workflows. And they talked specifically about this use case, about how they use Conductor to track signatures for documents using DocuSign. So what happens is it spins off a dynamic workflow for the number of signatories required for a specific document, and it can keep track of if the signature is completed. And once it's completed, it can run all the configured post-processing that needs to happen once the signature is done. So some of these workflows can run up to like months long, up to 6 months specifically, because that's the limit that DocuSign has. So this is an example of a long running workflow. And then one more use case I probably want to call out is like how Frinks, it's a network automation company. They use Conductor as their platform. And one of the things that they have done is they've created a UI on top of Conductor, and they allow their customers to configure the workflows dynamically. So this is like Conductor powering that platform that Frinks has built for Netflix automation, but also extends that feature to their end users who can now configure different workflows on top of the functionality Frinks offers. So these are some of the use cases that we've seen, and it's truly very generic and widespread. And then there are other scenarios where we have seen our customers use it for security automation and things like that.
So when you look at use cases like the media side of things that you've addressed with Netflix, like a multi-step workflow of producing media files at scale, can you shed more light on what is required to build a orchestration system that fits those kinds of use cases, that contrasts with other kinds of orchestration systems?
Yeah. So Conductor was created at Netflix way back in 2016, and it was primarily, maybe this is a good time to tell you a little bit of a history of Conductor. And this was when I spent time at Netflix, where I saw Netflix's second major pivot to be a company that produces content. The first major pivot was when they switched from DVD to streaming. And the second one was when they decided they have to produce content themselves, right? Which means, and the way the Netflix was going to do it was to do it globally, different languages, different countries. And they all are very nuanced. They have different rules, different regulations, different directors and producers does it differently. And all of this was leading us to a place where, we had to do a lot of engineering work. So there were a lot of microservices that were already available that, that had all the bits and pieces to get the job done. And, it was pretty easy for us to build new ones that for any specific API that was missing. But the real missing layer was how do we orchestrate these nuanced flows across all of these existing services? So that's when, Conductor came out. But before that, we were using an eventing architecture. So it was choreography. However, that wasn't very scalable because what we noticed was engineers started hand wiring these flows in dedicated services whose sole purpose was to manage this flow. What we were essentially doing was writing more services that was purely meant for just orchestrating and putting, or, the other option that people were doing was to pollute existing services to do more things than what it was supposed to do. For example, they were taking, we were using the image encoding service to also deploy into the CDN. And that was, kind of polluting the purpose of that original service. And the thing at Netflix was the platform team had great tooling to launch new services, which means like new services were getting churned out often, because it was easy to do. But it came with a maintenance headache and no one really knew how things were running. The choreography meant that the process was hidden behind events. And although we had tracing tools, it was very challenging to manage this whole thing easily. And the production process that I mentioned earlier means every other day we'll get a request that, we need to change the flow of how content is produced in Korea by a little bit because there's a new law, or a specific director wants to do this in a slightly different way. So all of these changes were getting really, really hard to manage. And that's when we introduced Conductor, right? Because we try to invert this from choreography to orchestration. And all of these flows became definition or configurations on the platform. This meant there is a lot of visibility that you get into the flows that were deployed on day one. And this visibility also meant like a lot of the changes that were being asked for was easier to do, easier to change. New engineers who were tasked with making these changes were able to like see this visualized flow, which means, they were able to make those changes with less risk and so forth. And this became really popular inside Netflix after we launched. And a lot of teams started adopting it. Netflix culture is unique in the sense that there's a lot of freedom and responsibility. So it's not like as an infrastructure team, we can come in and say, hey, here is a new way to do things and you should adopt it. But instead, it's something that we have to sell to the engineers. And the sell process was really easy in this case, especially with the observability and visualization tooling that we were showcasing alongside Conductor. So one team adopts it, we show that as an example to the next team, and they are quick to jump on it. And it quickly got adopted by many, many teams inside Netflix. And that's when, we also decided that it could be beneficial to the community if you were to release this into the OSS.
So when I talk to temporal, for example, the temporal workflow engine was incredibly hard to build, partly because it's built for, things like managing rides on an Uber-like app or managing like a multi-stage banking application where there's financial dependencies. And when I talked to Maxime, the guy who created it, a lot of what he said was that, this was his like fourth or fifth time writing a workflow engine. He had done it at AWS. He had done it all these other places. And it sounded incredibly work intensive. But I guess what I'm wondering is, is there a domain specificity to these different workflow engines? Like, do different companies or different use cases want different workflow engines? Or do you think that these different workflow engines have largely overlapping functionality and utility?
I think when it comes to functionality, there's a lot of overlaps. At the end of the day, you're orchestrating your flows through these engines. But I think the way, if I'm recalling correctly, Temporal uses workflow as a code mechanism. Basically, you write your workflows in code, while Conductor kind of does it differently. You use configurations for your flows. And it's also a very simple solution, what Conductor is, and it wasn't that hard for us to build this out, to be fair. This is essentially a task-based queuing system. It schedules tasks. So you configure a flow, it breaks it down into tasks, and whenever a task is ready to be executed, it schedules it. It's essentially a scheduling engine. So it's a really simple solution for anyone who's looking to adopt this, to understand how this works. And over the years that it existed, we've kind of abstracted away a lot of the problems that you run into when you're building distributed systems, such as handling transient failures, handling network issues, service unavailability issues, and then the whole paradigm of managing state when you're running a large decision tree as a workflow. So all of this is taken care of in Conductor, and it's a simple state management system on top of a scheduling engine that makes it happen. And it comes with versioning your flows and things like that. So I believe one big advantage, or one thing that we have noticed people adopting Conductor say is, it's really easy to understand how this works. I can imagine building this myself, but instead of doing that, I'm going to use this OS platform that does what I think is an easy way to orchestrate your flows. To answer your question, I believe it's similar in terms of outcomes for people who are using it. It's just different ways it operates, and whatever makes sense for you, right, will be your choice. And I think if you were to pick Conductor, you get some of those things that I mentioned, like being able to version your flows very easily, running different. Because in essence, what we are doing is we are taking these Lego blocks of code that you've built and deployed as microservices, and then you're building flows on top of it. You're just orchestrating that flow using this configuration that you deploy on Conductor.
Skyflow is a data privacy vault for sensitive data. Skyflow's mission is to radically transform how businesses handle their users' financial, healthcare, and other personal data, the data that powers the digital economy. Inspired by the data vaults that leaders like Apple and Netflix built to handle their customer data, Skyflow delivers a zero-trust data privacy vault as a simple and elegant API. Skyflow makes it easy for developers to protect sensitive customer data, manage data residency and audit requirements, and build data privacy into applications, just like adding payments with Stripe or messaging with Twilio. Check it out for yourself at tryskyflow.com and see what it's like to have a zero-trust data privacy vault as an API. That's tryskyflow.com. CloudBees Feature Management Community Edition gives you access to enterprise-grade feature flag management capabilities at no cost. CloudBees is on a mission to get as many development teams around the world developing progressively using feature flags as quickly as possible, without limitations in functionality due to cost. CloudBees made this decision completely free for development teams of up to 15 users. For any company on the fence about using feature flags, or for teams managing flags with a homegrown system that doesn't scale, CloudBees Feature Management Community Edition provides all of the functionality required to mitigate any of the governance or flag scaling concerns. Why is this news? Because no one else is doing it. Sure, there are a few open source tools out there with limited functionality, and sure, some of the more Enterprise-focused friends in the space have limited functionality and limited user-free tiers as well, but you will not find a more feature-packed feature flag management platform today being offered for free than the Feature Management Community Edition of CloudBees. Feature flag management tools are designed to be used by entire teams, and it makes sense to allow entire teams to use it together for free. Try out CloudBees Feature Flag Management Community Edition today, and you can try it out by going to cloudbees.com or checking out the link in today's episode. Thanks to CloudBees for being a sponsor.
That's the fundamental proviso of Conductor, I think, that makes it very attractive.
So, you mentioned that you listened to the episode about the data workflow orchestration system, Union.ai. When you think about like the design specifications for like a data-focused workflow engine versus a more general purpose system like Conductor, are there specific parts of the system that you see as more appropriate or less appropriate in each case?
Yeah. So I've not used Flight. I think that was the engine that was backing the podcast that I heard. But I've used Airflow before. One of the things that Airflow comes with is this ecosystem of operators that makes a lot of sense for your AI ML workflows. So you can kind of use these ready-made functions that are out there in your flow. So that makes it unique, or that makes it a better suitable engine in some situations. And this is something that we are working to overcome too, right? In Conductor, we're trying to introduce all of these operator-like functionality, which takes care of a lot of common things that people need. And that can be, once we have enough of those, it can be a great fit for like an AI-based or an ML workflow engine. I don't know if that answers the question. Yeah.
Yeah, it does. I mean, can you go a little bit deeper on that?
Yeah. For example, if you want to process like an S3 file or things like that, right? There are ready-made operators that are out there for some of these engines, which is like pre-made functions that you can import and start using. So that gives a lot of advantage to this tooling when it comes to specific use cases such as building workflows around ML or AI. And that's Conductor, on the other hand, has always been focused on your business flows, your service flows for handling so for example, things like dealing with a sign-up request from a user and doing all the provisioning for the user. These are like more like API transactions that happens as a chain of API calls that you need to make or based on the decision tree. And these are use cases I think better fit for Conductor. And on the other hand, if you have like a huge data processing workflow, which needs to talk to different databases and so forth, sometimes using an engine like Airflow would make better sense.
Okay. So if we're talking about multi-microservice orchestration, is the code that you're writing, like you're talking about provisioning resources, like, one service calls another to provision some resources and then needs to be able to do something about it. It needs to do something with those resources. So you have a chain of services that need to interact with one another. Is there like the notion of a promise or some kind of callback system? Like, I guess I'd like to know a little bit about the way that you handle asynchronicity. And then, you can also talk about just more generally distributed systems questions, like how do you handle, service failure or service not responding to you, stuff like that.
So yeah, this is what Conductor does really well, right? You can configure these asynchronous flows that you have, which is very common in like almost any business that you operate. And you can have that orchestrated by Conductor in a very, very reliable way. So the idea is that Conductor will look at your configuration, which is your flow definition, and it knows what step one, what comes after step one, and where does it branch off into forks, and where does it have to join back and all that, right? These are all defined as a configuration. And then the orchestration engine takes care of making sure all of those steps execute. And these steps can be very long-running steps. Like you can have something that waits for months, as I mentioned about the use case of DocuSign workflow from Black Diamond. Or it could be very short-running workflows, which is like short-running tasks like that finishes in microseconds, right? And it can continue to the next step. So the flow is managed by Conductor, which means the decision of which step to run next is the one that Conductor makes a decision on. And it schedules that particular task for you to execute. And this task that you're executing, they are your microservices code. It can be a Lambda function. It can be a service that you've deployed in a Kubernetes cluster. It can be a third-party service that you're integrating with. So you can bring together all of these different types of dependencies into that single flow. And it has inbuilt features that allows you to retry it if it fails. And these are all configurable. You can decide how many times you want to retry and what should be the gap between the number of times you want to retry. It also comes with features like rate limiting. So this is a very common feature when you build distributed systems. And when you're integrating with third-party services, especially, there is usually a rate management that you need to do. You can't call SendGrid's email API 1,000 times a second because they may not allow you to do that. So if you have situations like that, you can control that also through this flow definition. And that takes care of all of that. So Conductor basically has code and logic that kind of does all this functionality for you. And in terms of failures, it not only retries for you, but if your workflow ended up failing halfway through, you can use the support functionality later on to retry or retrigger them, or ask it to resume if it is stuck ask it to pause if it is stuck in a failure loop and you want to fix that problem before you want to resume that workflow. So there's all of these features that comes with an orchestration engine like Conductor.
How are those retries and distributed systems resiliency systems implemented?
So Conductor, when you deploy it, it has a few things that it comes with. One is a queuing engine. So it uses Redis as its underlying queuing mechanism. And there are different options that Conductor can be plugged into. So the open source version of Conductor has different implementations for the queuing engine. There are people who use ActiveMQ and RabbitMQ for their queuing requirements. And then there is a state management store that you need alongside this. So these are the two things that it depends on. The state management can be, again, there is a variety of storage options out there in the OSS ecosystem. Postgres, Cassandra, MySQL, for example. So combining the queuing engine and the state management engine, it makes sure that your data is never lost. Any task that you were supposed to run is always executed at least once. And that's how it manages resilience. And then there is enough redundancies on the service layer to make sure if one server of Conductor goes down, the next server that is living will pick up and until the server that went down is replaced. So all of that is kind of built into the architecture.
So when you decided to turn this into a product, I assume that there was a lot of work to make this functional as a cloud product. You'd obviously worked on it at Netflix, and, knowing what I know about how Netflix builds services on top of AWS and, does a lot of work around distributed systems, probably the system that you had inside of Netflix was very similar to what you've built as a cloud service. Is that accurate, or has there been anything notably different as you've taken this to being a cloud product?
No, the foundation is Netflix Conductor. What we do have maybe slightly different from the OSS is some enterprises that we've been talking to has requested for specific features that they want, like SSO integrations and role-based access control. So some of these things are just the features that we've added on top that we eventually want to push to the OSS as well. But that's the only main difference between what's running in the OSS and what we have as a cloud product.
And are there anything when you think about building a cloud product more generally, we've had a lot of interviews with people who build various databases and other scheduling systems, all kinds of distributed systems problems on top of the cloud. Is there anything you can share about taking one of these distributed systems products to market in the cloud that you can share?
Yeah, that's a great question. So the Conductor OS is right. I think I kind of told you earlier about how it has various options for the dependencies that it has for the queuing engine and the state management. So obviously not all of them are maintained to the point where you can run highly scaled workloads on it. So one of the things we did was to pick the best choice. In our case, we picked up Redis as the queuing engine and Postgres as our state management store. And we've kind of tuned that up to make sure that it can run scalable loads in production. So this is definitely something that we've done on top of what the OSS offers. And the other thing is being able to provision a cluster with a few clicks of a button. So that's what we've worked on since we launched last year as a company, and we've recently launched the product as well. So what it does is it's very similar to AWS console, where you can go in and provision a database or an Elasticsearch cluster, right? It's as simple as that. You go and click a few buttons and you get the entire stack provision for you. A fun fact is that we actually use Conductor as an underlying infrastructure for provisioning the systems as well. So I think What you need to think about when you're building a cloud product on top of some of these things like Conductor is how do you address the different use cases that your customers have? So, maybe there is a customer who only wants to run a small amount of workloads on this, and there's another customer who wants to run it at like very large scale. So in order to address that, we have different configuration options that leads you to slightly different setup based on how you choose. And then there is a lot of auto scale features that we need to build in for accommodating for spikes in like how people want to use. So these are some of the things we've taken care of when we built our cloud product.
So I'd like to shift the conversation a little bit more to engineering around actually building Orcus. So when you think about the different components of the system, if I'm building a workflow that touches multiple services, so like if I'm, for example, building a multi-stage workflow that spins up some infrastructure and then one service loads or pulls a video and transcodes that video into 5 different places on a transcoder ladder, and then you have to add, closed captioning to each of the transcoded sections of video, and then you have to, run data analytics across all of them. Or maybe, that's pretty simple because that's a pretty synchronous workflow. So maybe you could give me an asynchronous workflow. But I'd love to know about what the developer has to write to build that workflow and what's actually going on under the hood to actually schedule that workflow.
Yeah, that's a great scenario that you used. I think we can talk about that one. So, you get a content, you kind of break it down into blocks, you encode it, and then you have to transcode and stuff. This is something that happens in Netflix. So if you think about that, if you break it down, at the end of the day, say you go to the whiteboard and draw this out, it'll be those steps as you highlighted, like you get the file. Now you maybe want to break this down into smaller chunks so you can process it independently. And then each of the chunks get transcoded, and then you transcribe it maybe for subtitles and things like that, and then merge it back together. So this process, like if you think about how it works, is you have all these pieces that needs to run to make all those steps happen. And then there is this gluing that you need to do to create that entire flow. It's a 2-step process, right? One is you got to make sure that all of the steps you need are possible through some APIs or through the systems that you have, which is like encoding, transcribing, and all of those aspects. And once you have those pieces, we can call them as these Lego blocks. Then the next challenge is to come up and wire this up. And that's where, you probably use an engine like Conductor. So with Conductor, you literally translate what you drew on the whiteboard as it is. And you say, my step 1 is to get this file ingested. Step 2 is to create like a proxy for it. Or, you want to try and break it down into chunks to process them independently. And step 3 is for each of those chunks, you got to do the encoding work and so forth, right? So whatever flow that you had painted in the beginning is now what you would write as a configuration. So there's multiple ways you can do that in Conductor. There's a way to write this in a JSON-based data model. You're effectively representing your flow as a DAG inside using JSON. And then the second way you can do that is to use like the SDK libraries that we have to compose that using code. And the third way, which is not out yet, is maybe to use the drag and drop UI that we are coming up with. You basically come up with that flow. And once you have that flow, you persist that flow as a configuration in the Conductor platform and deploy it and start executing it. And what will happen is when the first file comes in, you want to trigger a workflow that runs that particular flow that you've just defined, and you can see that getting executed by calling those Lego blocks. And so the way Conductor will execute that is by going through the sequence of steps you've defined and then calling the appropriate Lego steps that you've previously defined and deployed.
And if you contrast that with a way of writing a multi-service workflow without a workflow engine, what are you gaining by having a workflow engine?
Yeah, this was exactly what was happening when we first built Conductor, right? I briefly touched on it. Like, what was happening is people were hand wiring these flows, meaning you kind of hand wire these exact steps that you would otherwise use Conductor for. The biggest advantage or the disadvantage of having doing it that way is that your flow is hidden behind in that actual implementation, which means you can't visualize it on how it actually gets executed. You don't, for something, if let's say that was running in production for a while, a new engineer coming in would be very hesitant to change a flow that is kind of hidden behind in code. So one of the things that you get out of the box with Conductor is these executions is visualized on exactly how it's defined and how it gets executed. So you can see that flow that you've previously defined for each of the execution instances that you trigger that workflow, right? And not only that, you can have different versions of it. And this is where it gets really tricky. If you were to do that using that hand-wired mechanism, you now have to have like a lot of if-else conditions, or if it is for this condition, trigger this variant that we have written. If it's for that condition, to trigger this other variant. But you don't need to worry about all that. If you were to use Conductor, you kind of have all of that visualized and configured as a configuration. So it's shifting that problem from the code complexity to like a configuration, and its configuration is proven to be very effective in these situations when you have similar things, when you want the same code block to run, but you want to run it slightly differently. So you kind of, most systems tend to direct you to use configurations for that. And that's what Conductor does for you.
RudderStack provides all your customer data pipelines in one platform. Easily sync data in and out of your warehouse, data lake, product tools, and marketing systems. State-of-the-art event stream, ETL, and reverse ETL pipelines enable powerful use cases, and flexible APIs allow you to integrate with your existing workflow. Sign up today or just get a free t-shirt for being a Software Engineering Daily listener at rudderstack.com/SED. That's rudderstack.com/SED. Time series data runs almost every technology, but building real-time apps in legacy databases can be a nightmare, as developers spend their time managing infrastructure instead of shipping code. InfluxDB is a time series platform built from the ground up to handle the massive volumes of timestamp data produced by sensors, applications, and infrastructure. It's preferred by developers who want to build analytics, IoT, and cloud-native services in less time with less messing around. Programmable and performant with a common API, InfluxDB gives you the high granularity, high scale, and high availability. You can capture, analyze, and store millions of points per second. See across all your data sources no matter where they are, and build in the language of your choice. Developers are happiest when they're building high-performing apps. Focus on the things you do best at with InfluxDB. Get started for free with influxdata.com/SEDaily. That's influxdata.com/SEDaily.
So you've got the core workflow engine built. You've got a cloud service for it. Where do you take the product next?
Yeah, that's a great question. So at this time, we are fully focused on doing two things, right? Two things mainly. One is to evangelize and rally the community behind Conductor. And then the second is to make it really easy for someone who's coming across Conductor from the moment they learn about it to running a massive production workload. So we are trying to optimize on that, trying to improve on that, trying to craft the journey that someone can take from when they first become aware of Conductor all the way to running like critical production workloads in production. So that's really where we're focused on right now. Where do we want to take it next? I think we've thought about that a little bit. We think we can help with like specific verticals that are using Conductor, for example, for infrastructure provisioning or for running like security related workflows and things like that. So we want to pick an industry vertical and maybe help with some of the common things that they often have to write themselves and maybe abstract that away as part of the platform is where we are thinking at this stage.
What's been your impression of the market? Are people formally ready to adopt workflow orchestrations? I guess workflow orchestrations as a concept has been around for a while. Maybe it's worth discussing. Why does this field get continually reinvented?
Yeah, I think it's the ecosystem that's also evolving around it, right? Like how you use systems, how you build systems. Traditionally, a lot of the engineering, resulted in monolithic applications. And it's only recently, you can see there's a shift towards microservices. Netflix was definitely a pioneer in this. It started doing this very, very early. But what I've seen in the market, it's only recently that companies are now adopting microservices, mainly because a lot of the companies are moving from a data center sort of environment towards cloud. When you try and choose cloud, you kind of use a platform like Kubernetes or something to manage your workloads. And when you use containers in Kubernetes, it naturally leads you to think about smaller services with all the support in the ecosystem that's available in Kubernetes, right? Like, for example, service discovery, service mesh. With all of that features, it makes it very, very easy to break up your services into smaller chunks and making it like microservices. And APIs and API contracts is way more easier than like managing a large monolithic application especially when you have a very large team. So I think the ecosystem around how you build applications has evolved over time. More teams are adopting microservices. And that's when you kind of run into this challenge of how do you want to orchestrate your flows around it. The legacy workflow engines were all very much centric on how you can run it on top of monolithic applications like the BPMNs and all of those workflow engines that used to exist in the past. So, but with this microservice architecture, you got to choose between choreography or orchestration. And when you do that, you want to rely on a platform that can do that for you instead of hand wiring it. And that's when this need for an engine like Conductor comes out. And I believe the timing is pretty much around the fact that a lot more people are now moving to cloud than before.
Makes a lot of sense. So as you look at the different use cases, like I look at these use cases that you have listed on your website, like food delivery workflows, patient management, patient medical records workflows, telecom subscriber and billing management workflows. There's really a lot of things. So as customers adopt Conductor or Orcus, are you seeing them refactoring existing code to include Orcus, or is it more like just new workflows that they have? I guess I could see them refactoring old code to use Orcus if the old code, for example, has like failover cases or something like that. But more generally, I would expect this would be like used for greenfield stuff.
Yeah, that's an interesting question. I think one of the reasons why people look for a platform to abstract away things is like the problems that they run into, right? Especially those hand-wired flows, all of those. That's our biggest sort of challenge too, or competitor, if you were to ask me. It's the existing hand-wired flows that people manage. So the challenge with doing that is you have to replicate the functionality of managing resiliency, the reliability aspects, the state management across multiple different use cases. So you're kind of repeating that process over and over again. And that's when, you kind of look for a solution that's out there. And most people that we are talking to or we've talked to are looking at migrating their existing services onto Conductor platform. And this is really one big advantage of Conductor. And I think kind of touched on it earlier about how it was designed around the fact that we need to be able to integrate with legacy services or brownfield applications. If I were to talk about that, right, if you just draw a circle around your existing service, and when you integrate Conductor, it's going to just live on the circumference at the edge. So it doesn't really get deep into your code, and you don't have to do any deep integrations. The SDKs or the client libraries that we publish are all very thin. It's just wrapping API calls for the most part. It makes it really easy to work with your existing legacy services. Like there are many situations where you want to integrate with that. Maybe there is a mainframe system that you use for processing your transactions that you can't replace with anything else. For example, in banks like JP Morgan, right? So these are situations where you don't want to force people to do something new, but rather like provide a way for them to integrate their modern infrastructure to also work alongside their legacy system. And that's doable with Conductor's architecture.
How active is the Conductor open source community? Is the project continuing to be engineered on?
Yeah, there is a pretty strong team at Netflix that's their full-time purpose is to manage the Conductor because it's pretty heavily used inside Netflix for a lot of critical workloads. And they've been continuously engaging with the open source community throughout this time, definitely answering questions that are coming through and any sort of support or feature requests coming from the community. Obviously, now that we also here, we want to take that up a couple of levels. We definitely want to be a resource for anyone who comes across Conductor and wants to try and use it and help rally the community around it. So we've been doing a lot of meetups lately. That's been a new thing that was revived when COVID came about. I think that the Netflix stopped doing like in-person meetups and all that, and we just restarted that. We're still through like video conferencing, but we want to soon start having some sort of in-person conferences around this. So we're really doing a lot more than before to rally the community. We have a Slack channel where you can ask questions, and there is a Discord channel as well. It's slowly gaining membership, and we hope to improve that over time soon. And just to add on, in terms of activity, there's quite a few pull requests and commits that are happening in the Conductor OSS, which has always been up to a decent standard, which we are also trying to make improvements on.
Are there any distributed systems use cases that are particularly challenging to orchestrate, even with the help of a workflow engine?
So almost all workflow engines by nature, is designed to handle asynchronous flows. I think one other thing that people often could benefit from if let's say this engine were to do that is to handle like real-time API calls. This is where, you have a single API call that's coming in and it needs to essentially orchestrate a flow by talking to different services to gather data from different services and to answer that call that the user has. This is something that it's not as straightforward to do with any of the asynchronous workflow engines today, and something that if any of the engines are capable of doing would be very, very helpful to the development community. So this is something that we are also considering on how we can reuse the orchestration engine of Conductor to even power real-time calls. And I think this is one scenario I can think of.
Does a workflow engine add or reduce latency to a net overall time frame that it takes to complete an operation?
Yeah, I think every workflow engine, like, when you're offloading the state management and scheduling aspect to the engine, right, that comes with the fact that you need to be able to schedule for stuff and get that assigned to a specific task runner. So it does comes with that cost. But if you were to hand wire this flow, that cost would still exist, especially if you were to use some kind of queuing mechanism to make this happen for the sake of resiliency, right? So that when you compare with hand-wired flows that use queues behind the scenes to make the orchestration happen, it's almost identical. But if you were to compare that with someone making API calls just in the code to make this happen, there's definitely that additional cost of having that engine orchestrate this flow for you, which is usually very, very negligible. Like it usually happens within milliseconds, the scheduling aspect and the decision tree parsing. So that comes at a very low cost, but it does have a price.
So I guess to wrap up, I'd like to get your perspective on cloud infrastructure from a higher level. So there's a lot of work around making distributed systems easier to operate, and Conductor is obviously one of them. There's AWS native stuff for building your workflows. There's infrastructure as code. And I wonder if you have any perspective on if the modern infrastructure innovations are laying the foundation for anything next. Like, what is the next wave of infrastructure management tooling going to look like, given that we have additional leverage from simplifying these previously complex workflows?
Yeah, I think the ecosystem is definitely, evolving towards a world where, a lot of things are abstracted away for you, I believe, which leads you to write less code to make your functionalities work. And also, you kind of get things that otherwise you had to manage it yourself, things like resiliency, the reliability of the system and all that, is kind of abstracted away into platforms. And that frees the engineers up for dealing with a lot more business-centric problems, what makes your business work, and focus on that. I think that's a good place to be, right? I believe that's a place we are slowly going towards. I believe all the companies these days are really eager to offload functions that are not their core business to either platforms like us or other third-party sort of systems that they can use easily. I believe that's really where the world is going. You can already see that, with a ton of things like, sending emails or SMS or collecting payments, you tend to rely on third-party systems. So I think the world of building software systems in a distributed way is going to be based on, a lot of the things will be, you can start using out of the box by integrating with these third-party services. And I believe that's where it's heading towards.
Yeah. I kind of wonder if there'll be more types of integrated platforms. Like I know one of your colleagues worked at Firebase for a while. Next generation clouds like Firebase and Netlify seem to combine a lot of these different tools and bundle them together in a simpler, easier to use overall platform. I don't know, maybe there's something similar that will be done in data orchestration. I guess there's some work around that, but yeah, I agree with what you said.
Yeah, for sure. Yeah. Definitely, when it comes to abstracting away those common problems, I think that's where the theme is always going to be. Even when we talk to customers, we realize, okay, there's this common function that multiple people want to run, so why not just abstract it away as a platform managed task? So you kind of get to write less code. I think that's where it is going, writing lesser code to manage complex flows, being able to change flows without having to invest too much in engineering resources and so forth, is probably going to be the driving factors of how new systems are going to be built.
Cool. Well, Boney, thank you so much for coming on the show. It's been a real pleasure talking to you.
Thanks, Jeffrey. Thanks again for having me.